Now, limitations of octet rules. In that one, first one is molecules with incomplete octet. Incomplete octet. What is mean by incomplete octet? In some compounds, the central atom is surrounded by the less than 8 electrons. Then that one is called incomplete octet. So this one is also called this compounds also called electron deficient compounds. I am taking one example here. Beryllium dichloride. Here, beryllium is a central atom, and beryllium is having only 2 electrons, 2 valency electrons. And chlorine having 7 valency electrons. So here the bond is between these 2 electrons, and observed here chlorine is having 8 electrons around it, and another chlorine atom also having 8 valency electrons around it, and but here central atom having only 4 electrons, that is even number of electrons, that is less than 8 electrons. And students, you can also observe this one in electron deficient compound matter. In this molecule, boron is boron having 3 electrons in this BF3 molecule, and that one is surrounded by 6 electrons only. That means less than 8 electrons. Okay. Then next exception, that is next limitation is molecules with expanded octet. Already you know this is also called super octet. Super octet. Now, what is meant by expanded octet? That indicates what? More than 8 electrons are present around the central atom in certain compounds. That compounds is also one of examples for limitation of octet rule. And I am taking one example here. PCl5. One more example is SF6. One more example is IF7. Okay. Now, already once observed here the diagram. In this PCl5 diagram, around the chlorine atom, how many electrons are present, students? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons are present around the phosphorus atom, and that means what? More than 8 electrons. More than 8 electrons present. Similarly, you can observe SF6 molecule here. Same also, and IF7 also. More than 8 electrons are present around the central atoms. Okay, that is called expanded octet. There is one limitation. In these two conditions, central atom having even number of electrons only. Third limitation is molecules with odd number of electrons. Odd number of electrons. So for that I am taking one example. NO, nitric oxide. In that one central atom is nitrogen. Nitrogen belongs to fifth group element and they are having 5 valency electrons and observed this one is bonded with oxygen, and oxygen is belongs to sixth group element. They are having 6 valency electrons. In this molecule, oxygen satisfied the octet and whereas nitrogen observed here. Nitrogen having how many electrons total? 1, 2, 3, 4, 5, 6. Sorry. Nitrogen having total 7 electrons. Total 7 electrons. So 7 is what? 7 is odd number. Then so this like these molecules are also not obeying the octet, but they are exist. They are exist. And taking one more example for you here: NO2, ClO2 minus. Like these molecules also example for molecules with odd number of electrons. And fourth exception is here octet rule is never explain the shape of the molecules. Okay, that is it fails to explain shape of the molecule. Suppose example H2O water molecule, it has bent shape. One more example NH3, it has pyramidal shape. Okay. And one more last limitation is it never explains or fails to explain noble gas compounds. See, here noble gases are already stable, that is they obey octet rule, and but they are also involved in the compound formation with high electronegative atoms like fluorine and oxygen. Here xenon, difluoride, xenon tetrafluoride, xenon hexafluoride. Like compounds also exist, but it is not explained. Which one? Octet rule. So these are limitations, and these are very important for competitive side. Okay, students. Small concept, that is Lewis dot structure. So here Lewis dot. Here Lewis scientist is explained or he is giving a simple notation to represent the valence electrons of atom. So here for that they introduced symbols. That symbols are called Lewis symbols. So Lewis symbols indicates valence electrons. Valence electrons.
Sir, closing. Memorize.
And it is used to calculate group valency. Okay. So already you know about this Lewis dot structure, but very important is Lewis dot structure is useful to calculate group valency. I am taking one simple table here. One is number of valence electrons. Example, symbol. Now suppose only one electron present, then example is hydrogen, or also you can take a first A group elements. Symbol is next. Suppose 2, 3, 4, 5 and 6. Then you can take a second A group elements like beryllium, and symbol is, and similarly you can take third A group elements. Example is third group element boron having only 3 valence electrons. Then fourth A group elements, example carbon. I am taking carbon, symbol is 4 dots. And fifth group elements, example is nitrogen. Lewis dot symbol is like this. So, and one more is 6th A group elements. Sixth A group elements. I am taking oxygen having 6 valency electrons. Okay. Now these are examples, some examples. And okay, students, in the next class we will discuss the types of chemical bonds, and in that one, first one is ionic bond. Thank you. Aku,